Thank you very much. Well, thank you all very much for the opportunity to address you. It's a real honor to be here. I've had a wonderful time the last couple of days. I'm only sorry that I couldn't stay here longer. What I'm going to talk to you about today is really, it's being presented as advanced science, but from the perspective of what you're studying, it's really extremely primitive. Let me use an analogy. What I'm going to talk to you about today is like somebody finding the shell of a nut and not actually knowing what it is, spending a lot of time studying it and assuming for many, many years that it's a completely dead object and has nothing to do with life at all. But then, finally, after many, many centuries, really centuries of studying it, concluding by examining the intricate tracings of the interior of this shell, that in fact, it must be the shell of a living object, and that there is contained within it something living and nourishing. That's not the shell itself. The analogy that I'm drawing here is that modern science for centuries and centuries has been studying with tremendous success simply the physical world and assuming that that is all there is, and that the physical world is a dead entity and there is nothing else. And only lately has it come to the conclusion that in fact, if you examine the purely physical world very, very carefully, you can find very subtle tracings within it, evidence that it is merely the shell and that there is a vital living substance that is not the shell itself, but something else. Now, I will explain to you furthermore how it is that modern quantum theory in particular is a kind of boundary science. And the subtlest quantum physicists understand this and have said this. However, if you were to spend your time studying modern quantum theory, you'll find that there's a lot of debate about this. So I'm simply going to present what I believe to be the case. I'm going to state this baldly and without contradiction, but you should be aware of the fact that you're simply hearing one man's opinion. And if you happen to have spare time to study quantum theory on your own, then by all means go out and read other people's opinion and come to your own conclusion for yourself. I want to emphasize that quantum mechanics and modern science has nothing to say about Kabbalah and has nothing to say about spirituality. But what it does say, when properly understood, is that the physical world is not the end, that there is something else. But it can't say anything about the nature of that something else. And furthermore, let me speak very precisely here. Modern quantum theory says that everything that we know and the power, the immense power that quantum theory itself gives us over the physical world requires two things. It requires that there be something other than the physical world, and furthermore, that we absolutely cannot know anything about what that something else is through the means of science. This is a subtle point. Oftentimes we want science to become a kind of instrument of spiritual exploration. But the best scientists, the best physicists have understood that that's not possible. Science can, in fact, be used as an instrument, at least intellectually, to lead us up to the point of understanding that there's something more. in the language of Kabbalah, it can in fact be an instrument for leading us to recognize the point in the heart. Oddly enough, even the most abstruse mathematics of quantum mechanics can be an instrument for allowing a person to recognize the existence of the point in the heart. But beyond that, it can't go. So now what I want to do today, because it is fascinating and interesting and can be explained relatively simply, in fact, is give you a small introduction to this in a way that you'll understand. I'm not going to use a lot of fancy mathematics, so you don't have to be frightened about that. I will reintroduce language that you've probably heard, if you've heard this language before and it hasn't made sense to you, I congratulate you, because it should not make sense to you. One of the things that prior Kabbalists have said, Kabbalists whom Rav Lightman greatly respects, is that the true nature of reality cannot be visualized. And one of the things that modern quantum mechanics has understood is something quite similar to that. I'm not sure it's the identical statement, but it's a very similar statement, that in fact you cannot use language, you cannot use imagery to properly understand the nature of physical reality. So for example, many of you I'm sure have heard the statement that matter, when properly understood, is simultaneously a wave and a particle. Well, that's a very easy thing to say. It rolls right off the tongue. And perhaps you picture something like this. And in your mind, somehow you put that little equation. But in fact, that's a completely meaningless set of symbols. And there's no way of actually making that make any sense directly. And it doesn't make any sense directly. However, in coming to understand what that actually means, you may begin to see and gain an appreciation of what I said at the beginning, namely that modern science allows us to understand the very limits of modern science, and that there is in fact something beyond the physical world itself. Now, to explain this to you, I'm going to first mention, very briefly, some rather astounding phenomena that are being developed in an area called quantum computation, at the very forefront of which in the world are a number of great Israeli scientists. I'm then going to go quickly to give a rapid presentation of an incisive experiment that was first described in pure thought form by the great American physicist Richard Feynman at Caltech way back in the 1960s. And this description has remained the quintessential description of the mystery of quantum mechanics. And in more recent years, this experiment has actually been performed physically using many, many different kinds of particles. And I'll try to explain to you why this experiment illustrates the limits of science and why it points directly to the existence of something beyond simply the material world. So first, let me point out that for centuries, the central, essential viewpoint of science, and this was the viewpoint held by Einstein, and it's the viewpoint held by the majority of scientists in the world today, is that there is nothing other than the physical world, and furthermore, that every event that occurs in the physical world, including every event in our bodies, and therefore in our brains, and therefore in our minds and in our interactions with one another, and since our brains are all just composed of physical particles, every single event, meaning every interaction of one particle with another, is 100% determined by the motions and the positions and the motions of particles in a previous moment in time. In other words, that the entire physical universe, all of us included, is nothing but a gigantic, dead mechanism, unfolding inevitably as it must, and that any perception that we think we have of being human beings, of having an awareness, of having emotions, of having intentions, in other words, everything that we're all doing here now, not to mention all the rest of our lives, is simply an illusion. There is no such thing as love, hate, desire, satisfaction. We're nothing but dead particles in very, very complicated assemblages unfolding over time. Now let me first, or second, I guess I've made a number of first points here. Let me second defend that point of view. Just briefly. For instance, essentially every medical advance, many of us here have had severe illnesses and would not be alive were it not for medical advances. Almost every modern medical advance is dependent upon that point of view and has succeeded because of that point of view. So that point of view has a great deal of power and cannot be simply dismissed with a wave of the hand. There is a tremendous amount or proportion of the world which seems to operate according to that principle, however offensive it is, and in fact, however brutal an attack it is on our, not only our sense of ourselves, but on our need for life to have meaning and purpose. Many modern philosophers, many modern lovers of mankind have recognized that the power of that perspective, in spite of how much good it has produced, has also inflicted a terrible wound, precisely because it implies that life is ultimately meaningless. The Nazis, for example, adopted that point of view in many respects wholeheartedly and became very efficient, not only as killers, but also as scientists. And we have indeed incorporated into modern science, including modern medical science, many advances that were first discovered by individuals who were killers. Modern medical philosophy is oftentimes extremely cold-blooded in its approach to human beings, precisely because of the efficiency of that point of view. Now, set that aside for a moment. If you look at computer science is a kind of extreme purification of the logic of this perspective. It's a distillation of this perspective down to the mathematics and logic of interactions, of mechanical interactions. And the basis for modern computer science is very simply the idea that you can have a physical entity, and usually that entity is thought of as potentially being in a number of possible states. This is a kind of notation used to represent a so-called vector. So think of this as a particle. This is particle 1, particle 2, and it can be in one of two states. And computers are, as you know, the kind of computers you use every day, are built up of devices that are so-called bits, bit-based devices, and you can have a whole bunch of them, large numbers of them, nowadays billions and even trillions of them. You can have very large memories composed of these devices that have physical entities that can be, each one of them can be in two states. Modern quantum mechanics, however, allows the following phenomenon. Difficult to appreciate the impact of this at first, where you can have physical entities that look like this. And what this represents is the possibility of having one single entity. These are not two entities. This is one physical entity, but it can actually be in two different states simultaneously. Now, just take that on faith, if you will, for a minute, that such things exist. And what happens is that whereas in a standard computing device, you end up with, you have n of these states. In a device like this, you actually end up with 2 to the n states. At a laboratory in Yale that I was at Yale that I was working at for a while, they're building a device that has just 400 of these entities. So in a typical computer that you use, as I said, you might have actually a few billion bits. Building a device at Yale with a mere 400 of these, which sounds like a tiny number, but potentially will end up yielding a memory of 2 to the 400th, which is a number so much larger than the total number of particles there are in the physical universe that it's impossible to convey just how great a number this is. And the people are talking about eventually creating computers with capacities so astoundingly great that it's as close to physical magic as you could imagine. Now, how does such a thing even begin to come into existence, and what does it mean to talk about states being two different states simultaneously at once? Here's the origin of that. And this goes back now to what Feynman originally explained almost 50 years ago. If you have a tank of water and you have a device that just moves up and down and creates waves from two different sources, eventually what you'll end up getting is a so-called interference pattern as the waves intersect. The interference pattern is nothing more than the radiating points of intersection of the waves. This is a very, very well-known phenomenon, and it's easy to calculate the mathematics of where these points of intersection are going to be. If you perform a similar experiment, and instead of having waves, you use particles. For example, you're shooting little tiny atomic bullets out of a gun, and you arrange it like this. First of all, if you have a gun here that's spraying bullets out, individual particles, you have a screen to detect them, and you have this screen is put here in order to ensure that you have just a very narrow beam of particles. You shoot these particles out. Within very narrow limits, you'll always detect the particles appearing at a predetermined spot. If you now make a slightly different experiment, create a screen with two holes, and you put a block on this screen, you have your detector here, your bullets spray out in all directions originally, this one is blocked, this one is open. Within very narrow limits, you'll detect your bullets coming there. what you expect is that if you have an arrangement where you allow both holes to be open, you have your detector, and bullets are coming out through both places, that you'll have two distinct locations where they're going to hit the screen. But in fact, what has been found, so long as the size of the bullets are small enough, or actually, let me put it more precisely, so long as the size of the bullets and the size of the holes in the screen and their spacing are properly related to one another. That's really all that's required. Technologically, that can be quite difficult to do, but it has in fact been done, and it's been done with relatively large atomic particles, whole atoms in fact. If you arrange your experiment properly, what in fact happens instead is that you find that you will end up detecting these bullets or atoms at regularly spaced intervals all along the screen. In fact, all along the screen, all the way out to infinity in both directions, but that you'll find most of them here, and it will rapidly drop off going out in both directions. And if you measure these heights, it's the intensity of these heights, the number, the proportion that follows a so-called wave pattern. That's the origin of the claim that quantum particles are simultaneously waves and particles. Now, what is it that's a wave? Well, first I'm going to answer that question slightly inaccurately, and then I'm going to correct the inaccuracy. But it'll be easier if I answer the question slightly inaccurately first, easier for you to understand it. What is a wave here is the probability distribution along the screen that you will find a particle. So what is being transmitted from here to the detector is a traveling wave of probability. The probability that the particle will be found at a particular location. Now let me correct that. When you measure these heights, you find that the heights don't actually correspond. The mathematics of it doesn't quite exactly correspond to a traveling wave of probability. It corresponds to a traveling wave of the square root of a probability. And in fact, some of the square roots are negative. Now, if you think about it, probabilities in the real world only go between 0 and 1. A probability can be 0. The probability of something happening can be 0. It can be 1 out of 2, 3 out of 4, 4 out of 5, 9 out of 10, or 1. It can't be a negative number. So whatever it is that is propagating through space is something that does not exist in the physical world, but yields results in the physical world. Furthermore, if you perform this experiment in such a way, I'm going to simplify the drawing a little bit, that there's only one particle coming out of here between the time that it leaves the gun and hits the detector. So you've measured how fast it's moving, you've measured the distances, You've turned down the frequency of shooting so low that you're sure that there's only one coming out. In fact, there could be one coming out every week. You still end up with the same probability distribution that looks exactly like the interference pattern that I showed you of two waves interfering. So in other words, what you have are probability waves, or square root of probability waves, that are interfering with each other, even though you have one particle a week coming out. It's worse than that. If you set this up such that you shoot one particle out, you then disassemble the entire experiment, walk away from it, come back a year later, reassemble the experiment, now shoot out a second particle, you end up with the same phenomenon. In other words, this interference pattern will reoccur, will build up over time, the density of particles being located, even though you have disassembled the entire experiment, gone away, and reassembled it once again. Now, there's one other point, and this is the final point about science that I'm going to make, about the physics, and that is that even though this probability pattern gets built up with absolutely precise mechanical accuracy, and does so in this astounding way that seems to transcend time and space, but it's perfectly mechanically deterministic. The mathematics of it are absolutely precisely known, so well known that we are now using this phenomenon to build astounding computational devices. And here's the kicker. If you shoot one bullet out, I can tell you with precise mathematical precision exactly what the probability is of where along here the bullet is going to hit. But what I absolutely cannot tell you, and what quantum mechanics says we are absolutely precluded from knowing, quantum mechanics says, in fact, that there is nothing in the physical universe determining it. This is the central point, that there is nothing in the universe determining exactly where it will end up. In other words, the probabilities, the likelihoods, when you look at many millions and or thousands and millions of particles, that is precisely mathematically determined. But which particular location any one particle will end up is determined by nothing in the physical universe. And so a number of the best physicists have recognized that there is a deterministic component in the physical universe that works just as we have always thought, but that there is something else at work, woven into the fabric of the universe itself, very, very subtly, not disturbing the mechanical unfolding, so that it looks to us, it looks to somebody who doesn't look sharply enough as though everything is mechanical. But if you look at it carefully enough and understand it, you see that in fact each individual event is being influenced by something that is not part of the universe. And since, furthermore, the theory itself requires that it not be part of the universe, we're left with a boundary. And a number of physicists have said that, in fact, quantum mechanics is a boundary science. It is the science that shows us the boundary of what is possible for human beings to know simply through examining the nature of the physical universe itself, that there is something else going on that science can never tell us about. So, those are my comments. I don't know, Rav, if you want me to take any questions or simply stop there. Avihu, do you know?
האם אפשר מתוך זה לעשות איזה מין המשך לחוכמת הקבלה? נראה לי שיש המשך, מתוך הקושייה הזאת, שהם מגלים שיש איזה כוח נוסף שפועל ביקום, האם מתוך זה יכולים...
From that question, Rav is asking, Rav has a question. From that question that you showed where the boundary of science is, do you think, or is there a way to carry on to what's going above that boundary and to connect it to the wisdom of Kabbalah? Or how, from that question, how can we reach out to the wisdom of Kabbalah?
Sure. The question was...
Or maybe a different theory.
The question was, is there a way of relating this to the wisdom of Kabbalah? Now, I'll simply offer my opinion. And let me emphasize that. This is simply my opinion. I'm not claiming that my answer is the correct answer. It seems to me that it is an essential part of what quantum mechanics claims in its theory, that from science we can know nothing about the nature of what is beyond the physical world. That's the subtle, very powerful nature of the boundary condition that is quantum mechanics. It on the one hand, it is what gives it its immense, extraordinary, unmatched power in the physical world. But it also is, if you will, it's a condition of humility. And for me, it's been a source of great reflection, or an opportunity for great reflection on the nature of not only what science can't do as science, but also, again, for me at least, it has been an opportunity for me to reflect on how important it is for the individual human being not to be told from the outside, for science to say, this is the correct direction. For science to say, science points towards Kabbalah as the correct direction. But rather, it's as though quantum mechanics, or let me put it better, that a close examination even of the physical world hands to human beings a great responsibility by saying, look, examine the physical world carefully and you will discover that there is something tremendously important beyond this world. Science cannot tell you what it is. It is part of your responsibility to decide what it is. Now, in listening, for example, to the Rav lecture, but not only the Rav. The Rav's lectures I find unusually moving, but Rav is not the only person whose words suggest to me the importance of that in the act of returning love, there must be the freedom to reject love. That when you, even in human love, you don't want the person who loves you to somehow be driven to love you with no capacity to reject you. You want, the freedom to reject you needs to be there. And so it seems to me, again, this is merely my opinion, that the Creator offers us the opportunity to consider the words of Kabbalah and to reject them as untrue. And that it is, it somehow strikes me as not in the scheme of things that an examination of the physical world could, in a sense, force the conclusion that Kabbalah is correct. That it requires something else in the human soul to make that assent. And that all that the physical world and science can do is lead one up to that boundary and help in the recognition that there is something beyond the physical world. Yeah, certainly. Yes, sir.
What do you mean that one particle can be in two places?
Okay, the question was, what do I mean that one particle can be in two places? Now, so let me be very precise here, because I used a similar phrase here now, and I used that exact phrase in a movie that I was in recently, and they actually mean two different things. So let me clarify this. It is a general principle in quantum mechanics that particles can be in multiple states, not necessarily places. This is called a superposition of states. When a particle is in a superposition of states, it is not being detected by anything, and it is not interacting with anything. Let me also clarify that detection or observation is merely one form of interaction. There can be impersonal forms of interaction with a particle that have nothing to do with detection or observation. So if a particle is floating freely in space, it can be in multiple states. For instance, a particle of light, a photon, can be simultaneously in a left circular polarization state and a right circular polarization state. And I'm talking about here states of polarization of the sort that your sunglasses deal with. It's nothing out of the ordinary. It doesn't have to be two physical places. If we were to talk about states in this sense of superposition and mean by that physical location, the particle wouldn't actually be in more than one location. It would be in, we would have to talk about something like position states, in which case there would be nothing in any location yet. When a particle is in a superposition of states, when it's in more than one state at the same time, nothing is interacting with it. That would be like the particle here before it interacts with the detector. I've drawn this particle as a point. But if I were to be more accurate about it, I would draw it as a big question mark. Because this point implies that the particle actually is at this location at a certain moment in time, implying that it's at this location at another moment in time, and so on. But this phenomenon of this wave, this probability distribution, implies that the particle must have gone through both this slot and also this slot, because otherwise there can't be an interference pattern. And yet, I explained to you that this occurs even though there's only one particle, and you can disassemble the experiment and reassemble it a week later. So the whole thing is completely impossible using pictures that are visualizable. The true picture of reality, as ancient Kabbalists said, is not something that you can picture using visual imagination. It's beyond visual imagination. The other statement that I made about particles being in two places at once, which is something I said in the movie, refers to a unique condition called a Bose-Einstein condensate, which occurs near absolute zero when billions of individual particles merge together